Welcome to your lesson on solving linear systems by graphing. This is a big idea in math. It keeps coming back to you over and over again. You'll see it in all levels of math, so make sure you master it this time around. Okay, there are basically three types of linear systems. A system means you have more than one line in one plane. So here's one line, here's another line. That's now called a system. And this system here, if I have one line like that, one line like that, those two lines meet at one point, so we have one solution and the lines intersect. Over here, you can see a red line and a blue line. They're overlapping. So they're actually, in essence, the same line, but two different equations can produce the same line. So those two are overlapping. So there's actually, those are called coinciding lines, and there's infinite solutions because where those two lines meet is at every single point on the lines, and there are infinite points on every line, so they meet at infinite number of points. Infinite solutions. And here we have parallel lines, and there's no solution because, as you know, parallel lines will never intersect. So when they never intersect, there's no solution. These are also called consistent independent systems. This one's called consistent dependent, and this is called an inconsistent system. So now let's take some notes on the notes page that was given to you in class. The page begins with this section here where we add the types of lines. Let's begin here where we have intersecting lines. Let's sketch two lines first that intersect. You can sketch any two lines. There's one line, there's another, and those two intersect. And they intersect at one point. So if you look at that, they have one solution right there. So I'm going to put one solution. All right, now let's go to the next one. Coinciding lines, if you remember that from last slide, coinciding lines are lines where you have one right on top of the other. So I know these don't look like they're exactly on top of each other, but I just wanted you to see the two lines, but they're right on top of each other. And there are infinite solutions again because they meet at every single point. And then you can have parallel lines which look like this, and these lines will never meet. So when you have number of solutions, it's no solutions. Now let's get all the vocabulary up here. Again, the ones where there's either one solution or infinite solutions, that means there's a solution possible, are called consistent systems. And the kind where they're parallel and there's no solutions are called inconsistent. And then consistent has two types. When there's one solution, it's called a independent system. And when there's infinite solutions, it's called a dependent system. All right, so that's a lot of vocabulary there, but the key points there are about having one solution here, infinite, and no solutions when you have parallel lines. Let's look at some examples. First of all, I'm going to look at the first two problems that were given to you on the worksheet you started in class. These were meant to be simple problems, and the reason they're simple is because all these lines that are given to you in mx plus b form, which is the form that is easy to graph. You don't have to change anything here before graphing it. So let's go over just the first two so you can remember how to do those, and then we'll go on to the other problems on the new worksheet with the notes. So in this one here, first step is to look at it and say, what is the slope? So in this one, the slope is always the thing in front of the x. Negative 5/3 is the slope. And in this one, the slope is going to be 1/3, that number there. So now that you have the slope, you can graph this by looking at the other number, which is your y-intercept, and you begin there. So y-intercept here is 3. You begin at 3. Then you use the slope to find another point on the line, and the slope says minus 5/3. So I'm going to go down 5 because the top numbers always are rise, which means up or down. So we're going to go down 5, 1, 2, 3, 4, 5, and over 3, 1, 2, 3. And I'm going to put my next point here. And then you connect that and you have a line. And one way to double check you've drawn the line the right way is you look at it, it has a negative slope, and this is a line that's going down, so negative slope line. That's perfect. This one now, the y-intercept is negative 3, so I'm going to go here. And then the slope is 1/3. The slope is 1/3. So from this point, I'm going to go up 1 and over 3 right to here, to that same location as that one. All right, so now you connect those and you have your second line. And again, the second line here has a positive slope, and this is a positive line. It's going up, so you know you've graphed it right. These two lines intersect at this point, so that is our solution. That solution is this point, which is at 3, -2. 3, -2. Next, this one. All right, this one's slightly tougher because the slopes are not as evident. There's still written in y equals mx plus b form. This first one here, the number in front of the x is 4, so that is our slope. However, we're going to write slope m equals 4/1, because when you see a number and there's no number on the bottom, you can always write it as something over 1. So your slope is 4/1. Second one, the slope is, you don't see a number here, but when there's no number, you have 1x, so that's negative 1x. But again, negative 1 can be written as negative 1 over 1, so our slope there is negative 1 over 1. Let's graph this one. Y-intercept, this number is 3. So you begin at 3 on the y-axis. Then you use your slope, up 4 over 1. But up 4 will take us off the graph, so we can always go the opposite direction. 1, 2, 3, 4. Now you have to decide over 1, is it this way or is it this way? Well, if you look at that slope, it's positive, 4 over 1. So this line in the end has to be an upward sloping line. So it's going to have to go like this, up. So down 4 over 1 this way will work. Because now when you connect that, it's a positive slope line. It's going up. If you had put the point here over 1, it would make a negative line. No good. All right, next one, we have a negative 2 as your y-intercept. Go right here. And then you have a slope of negative 1 over 1. So from there, you can go down 1 and over 1 right here. Connect those to make that line. Again, look at that line. It's going down, and that has a negative slope, so that makes sense. These two lines meet at this point right here, which is negative 1, negative 1. That is our solution to that system. Okay, now let's take notes again on the back on the page where you took home for the notes, the page where you had the coinciding and dependent, independent, all that. And there's the example in the middle of that page. This is again one of the simple ones where you have mx plus b form, so you have your y-intercept and your slope. In this case, the slope is 2 over 1, because again, there's a 2 here. We can write it as 2 over 1. So we begin at our y-intercept of 3 right here, and then we use our slope 2 over 1, up 2 over 1 right here. Connect those, you have your line. And again, it's a positive line, it's going up, positive slope. Next one here, we have a slope right here of negative 3 over 2, so I'm going to write m equals negative 3 over 2. Begin at our y-intercept of negative 4. From there, you go down 3 over 2. It says minus 3 over 2 negative, so down 3, but that'll take us off the graph. So again, we're going to go up this time. 1, 2, 3, up 3. Now you have a choice. Do you go left 2 or right 2? You look at that slope, it's negative, so the line has to be slanted downwards. So I'm going to have to go up 3 and left 2, because now that will create a line that's going down, which matches our negative slope. So these two lines intersect right here, and that is a solution to this system, and that solution is at negative 2, negative 1 is a solution. Next one, slightly more difficult. It says find the solution by solving for y, then graphing. These equations are not written in y equals mx plus b form, so it's not really graphing form. So if we rearrange them, we can graph them more easily. So this one, to solve for y, I'm going to take this 8, I'm going to move it to the other side by adding 8. So now this is 2y equals negative x plus 8. Then I need to get rid of this 2, divide everything by 2. When this is divided by 2, it's just y. When this negative 1 here is divided by 2, we get negative 1 over 2. And when this 8 is divided by 2, we have 4. So this is now good form for graphing. We, again, find the slope. The slope is this number, negative 1 over 2. The y-intercept is 4, so I'm going to begin there, 4. Then use the slope, negative 1 over 2, so down 1 over 2, put a point right here. Connect those, you have that line. Again, it's going down, which matches our negative slope. Let's do the same for this one. Let's solve it by first, we're trying to get y by itself, so let's move this 9x over to the other side by adding 9x. So now we have 3y equals 9x minus 9, so that 9x has gone over to this side. Now there's a 3 here, we don't want that, divide everything by 3. So this divided by 3 is y, this divided by 3 is 3, and this divided by 3 is negative 3. So our slope here is this 3, which can be written as 3 over 1. Our y-intercept is negative 3, so you go negative 3. Then you use the slope to find the next point, up 3 over 1, up 1, 2, 3 over 1 right here. Connect those, it's an upward line, that means a positive slope, that makes sense. Those two lines intersect right here, so our solution is 2, 3. All right, let's look at one last one. This is the last one on the bottom of your notes page. We have this equation, which is in y equals mx plus b form, and this one is not. So this one we can already get the slope and y-intercept. The slope is this number, 1/2. The y-intercept is negative 4. So let's go to -4, then use our slope of 1/2. So we go up 1 over 2 right here. Connect those. There's our first line, positive slope. All right, this one, let's solve it for y. Let's move this 3x over first. So minus 3x, and it becomes minus 3x on this side. Then we have this 4 here, divide everything by 4. This divides by 4, you get y. This divided by 4, you get, so there's the y. This divided by 4, you can leave it as -3 over 4. And this divided by 4 is 2. So let's graph this. It's now in graphable form. This is your slope, -3 over 4. This is your y-intercept of 2, so I'm going to go to 2. Slope is -3 over 4. 1, 2, 3, and then over 4. 1, 2, 3, 4 right here. Connect those, and then those two lines intersect. The problem, however, is where do they intersect? The previous examples were pretty simple. They intersected right at the corners of this grid, and it was easy to say what point that is. But here you're like, where is that? Well, the x value is 4 point something. The y value is -1 point something. So you're left wondering 4 point what, -1 point what? It's unclear exactly what it is. And this is actually one of the problems with solving systems by graphing. You never quite know exactly what that solution is. So it's one of actually the bad things about solving this way. We'll look at other methods later. Anyway, for now we'll put that, and you can try to estimate as close as you can. So this can be solved in our calculator to get the exact solution. We'll look at that next time in class. For now, concentrate on practicing this skill on the backside. Again, these are going to be tougher than the ones on the other worksheet I gave you, because these ones have a lot of situations where you have to solve, rearrange and solve for y, like there, that one you have to rearrange. All of these you have to rearrange. You have to move things around so that you get y equals mx plus b form. The only easy ones are the first four here, which are already set up for you in the right form. Just a quick note here. Here you can see the slope is 3 over 2. But here, what is the slope? Well, you don't see a number. It's going to be -1 over 1. And anyway, proceed like that by graphing those, finding the solutions. Once you find the solutions here, you should be able to find the solution here. And if you find an answer here where the two lines intersect and you find the answer here, then you cross out the two letters above it. And in the end, when you've crossed out a bunch of letters, some letters will remain, and those letters will be the answer to this riddle, which is, what did the teacher do with Ogre's cheese report? It's a really funny riddle. You should work hard to finish this off and get your answer. Enjoy.